Excellent. Greetings, everyone, and welcome or welcome back to our Future of Cloud series. My name is Dalibor Petrovic. I'm a partner at Deloitte, and I lead our national CIO program and get a pleasure to host these sessions, these live webcast sessions that we've been organizing and delivering now for actually over a year. July 14th, Wednesday, we have a pleasure to welcome a whole panel of experts who are going to talk with us on the topic of the future of cloud, and more specifically, future of cloud in the context of machine learning, artificial intelligence, data science. This is episode 2 in our 3-episode series on the future of cloud. We wanted to bring this series forward because we are experiencing that most of our clients, all of our clients right now are at some stage of the cloud transformation journey. We see this as a major tectonic step change in the way not just IT organizations deliver information and technology, but rather how all of our organizations and clients experience and engage with technology and data. This is probably as large a shift as probably last time something that this big happened was the introduction of internet or the proliferation of internet in the mid-90s, and prior to that the shift from mainframe to distributed computing. So this is a dramatic shift. And we wanted to actually have a very practical conversation about what we are seeing the future of cloud is. Where are all these things actually heading to? So these 3 episodes revolved, first of all, the first topic was cloud and cyber. How do you set up your own environment, cloud environment, to be secured by design? And it was a very good conversation. If anybody's interested to see the link, please email me after this, and I'll be happy to send you the links to that conversation. Today's session is going to be all about machine learning in the context of cloud, and we will be unlocking what we call a 3-pronged promise of machine learning on cloud. And then the last session that we're going to put in a couple of weeks' time is going to talk about the impact of cloud and the future of cloud as it relates to your talent, which is another very, very important critical conversation to be had. Now, when we talk about the promise of cloud in the context of machine learning, there are 3 prongs, as we call them, that we are going to unpack today. The first one is technology. It is the appreciation and discovery for many that both hyperscale cloud providers, but also specialized organizations, actually extend and have developed and are offering machine learning algorithms pre-trained to you as cloud users, and other technologies that typically or genuinely could not be affordable or available to many organizations otherwise. So this promise of technology and access to technology, the promise of time, which is related to technology, quite frankly, in that a dramatic acceleration of your ability to leverage those application development with instant infrastructure, which is what traditional cloud platform offers. But on top of that, these pre-trained solutions, cloud machine learning services and development, existence of models and frameworks that really can accelerate your usage of machine learning and AI capabilities straight from the cloud by cloud providers. And then the last one around talent, and the fact that we now know, of course, that cloud providers offer access to their talent that for most organizations is very, very difficult to recruit, very difficult to retain. And that we think is also a major, major plus. So that's going to be what we'll be covering today. For the audience members, at the end of this conversation, which is designed to be an hour long, we are going to offer a Q&A session. So If you have any questions or comments, or would you like any one of our panelists to answer a specific question, please do submit your questions throughout the conversation using the QA feature of this cloud of our Zoom platform, and we will moderate a number of these questions at the end. So that will be a way. And of course, if afterwards you actually want to connect directly with any of the panelists, please, of course, let me know. We'll be happy to send you the contact information to our distinguished panel. And it is a distinguished panel. I'm very thrilled to be joined by three of my colleagues and great friends. Kevin Lavin, who is a director of Omnia AI practice, which is Deloitte's AI practice. Thank you, Kevin, for joining us. Lynn Luo, a senior manager and our data science leader, also with Deloitte, with Omnia AI practice at Deloitte. And Mario Morgado, a director also of our Omnia AI practice. So surrounded by very, very smart and experienced people on this topic. Welcome, thank you very much. And let's start the conversation. So Mario, the question really for you to kick us off. I set up this promise of hyperscalers and innovation that comes through hyperscalers. What is your take about that whole concept of innovation using hyperscalers? Can you kick us off with that, please?
For sure. Thanks so much, Dalibor. So just by way of introduction, I'm Mario Morgado. I'm responsible. I'm the National Cloud Data Director. So I manage all of the data engineering with all of our hyperscalers. I've been with the firm for a little over 5 years now, and been doing this perhaps not as long as Dalibor, but for the last 25 plus years. So a multitude of experience across a number of different industries. So with respect to the topic today, I'm pleased to speak on this topic and honored that Dalibor invited me to this conversation. So what we're seeing in the marketplace is truly exciting right now, specifically with respect to this exponential rate at which data has grown and continues to grow, with many organizations heavily invested into data warehousing and data lake architectures, capturing everything from consumers inputting their personal preferences to social platforms on many social platforms, and telemetry data that is captured through IoT devices. So this rapid growth in data has allowed us to evolve a number of capabilities to provide differentiated data digital experiences in virtually every interaction that we have. By deliberately and proactively predicting on decisions around what products we should offer to consumers, what services are they most interested in, enabling human-like digital conversations and identifying risks, and the potential impacts of a prescribed course of action. So having all of that information at our fingertips has been critical over the last several years. So if we take a look at someone like Dow Chemical, for example, and how they were able to leverage AI, artificial intelligence, machine learning, and their Internet of Things through a video solution, also leveraging Microsoft Azure Video Analyzer to continuously monitor for leaks using IoT-enabled cameras that would notify operators through SMS and email if a potential containment event is occurring. So not that if it will eventually occur, that it in fact is occurring, and hence improving security and environmental safety for them. There's truly amazing things that are happening right now, all enabled through data. So enabling these capabilities requires an agile and elastic set of resources, everything from tooling to frameworks capable of connecting, storing, cataloging, and structuring this data in multiple areas, such that you'll spend more time understanding the importance and the significance of the data through feature engineering and model development than actually building data centers and infrastructure to do that. So the ability to do this quickly, leveraging a common set of data standards and governance, has helped several of our clients successfully embed AI into their data-driven solutions with meaningful outcomes across all of their enterprise.
So I'm sure you've had direct sort of first-hand experience working with actual clients, actually solving actual problems using what you just described. Anything you can share from your personal experience regarding this?
Yeah, for sure. Thanks, Salvador. So I personally experienced this firsthand with one of our largest transportation organizations, where they approached us to help partner on a business problem. Essentially, they were wanting us to proactively help them identify the probability of a maintenance issue occurring in real time that would lead to them taking that asset out of service for maintenance. So taking an asset out of service, carries a significant cost and potential revenue loss. However, the risk of that asset breaking during normal operation would likely cause a much more significant risk to them. So what we were able to do is we took this problem at hand, and through this preventative validation and repair, we were able to look at how we could help them reduce the risk and increase the overall lifespan of the asset. So this type of analysis was performed by reviewing hundreds of gigabytes of images that are taken in real time of the normal operation of the asset. And then we compare these images that are taken across a repository of images of defective and normal assets of similar nature to draw an analysis and be able to predict in real time whether or not the asset is prone to a defect happening. So by leveraging cloud storage and data management best practices, a lot of the edge device management and image recognition and machine learning models, we were able to derive a predictive model that had a 90% plus accuracy in just under 5 weeks to understand whether or not we were going to it was required to take that asset out of service for repair.
Yeah.
So this experience was made possible only because hyperscalers are packaging these common machine learning models to help our data scientists and developers drive these types of innovations without having to focus on infrastructure or networking.
So this is fantastic to hear. So you say 5 weeks in duration, leveraging hyperscalers' existing algorithms that are to a certain degree pre-trained.
Correct.
You point them towards photographs of what works and what doesn't, and when the asset is broken. So you mentioned transportation, so I'm going to assume that this is not only just about increasing savings, but also potentially security and safety, right? So this is really very, very cool.
It really was. It was super significant for this organization in that they were able to immediately reap the benefits of scheduling of all of their maintenance crews and understanding, the overall cost of the asset and repairs.
Yeah. And it is really important to hear stories like this, because this actually makes it real. People do not gravitate when we talk about AI and machine learning. People don't necessarily naturally gravitate to use cases like this. But this is where the rubber actually hits the road. This is where savings and security actually gets increased. So this is really cool. So when you think about like your experience and other experience you've had in this, where would you suggest organizations truly need to focus on in order to either start or accelerate getting stuff like this done for them?
Yeah, so I think business cases for leveraging cloud and data and machine learning vary from driving growth to optimizing operations or gaining a competitive advantage through hyper-personalized digital experiences. However, they're all founded in a defined business problem that is specific to that organization as well as their overall industry as a whole. So there needs to be a sufficient diversity in data points to support a solution. So I think it's important to note that not all business problems can be solved through artificial intelligence and machine learning. However, it's been reported in a recent survey that 74% of organizations believe that AI will be integrated into all enterprise applications over the next 2 years. So I think with that in mind, we need to focus on 4 different things. What is our business problem? What are we really trying to solve for? Who do we need? Do we have the right talent? Do we have the right subject matter experts to actually speak intelligently on the data and the problem and what we need to solve it? What tools are going to be required to help us solve this? So, do we have the tools in-house, or do we leverage hyperscalers? Do we want to be in the tool industry, or do we want to be, we want to really be in the data industry and in the business that we're into, as opposed to trying to solve IT problems? And then where are we going to get the data points? So if we need diversity of data, where is that data going to come from? So with all of these, I've sort of noticed a pattern nationally with a number of our clients that sort of fall into three basic camps. So there are those that are all in. So they will have completely embraced hyperscalers, where they're building out and leveraging, AI, data, machine learning platforms and data labs, where they're doing this and accelerating this very, very quickly. So that's one camp. The other camp is those that I would say, are leveraging hyperscalers that have built machine learning accelerators. So image recognition tools, text to speech tools, natural language processing type algorithms. So where they're leveraging that pre-packaged model to build innovation into their enterprise. And then the final bucket is where I'm finding that there is an influx of organizations that are leveraging what I would call a out of the box pre-packaged AI model that they are subscribing through an API. So some organization may provide a predictive model that they then subscribe and get an answer back to. So it's almost like AI as a service, if you will. Yeah. So those are sort of the three camps that I'm seeing there. But I think it would be interesting. I'm glad that Kevin and Lynn are here, and perhaps Kevin can provide some of his experience in terms of what he's also seen in terms of those three buckets.
Yeah, thanks very much, Mario. So my name is Kevin. I'm a director in the data science team here at Deloitte. I've been doing AI for about 20 years. I got serious about it in 2003 when I started my graduate studies in the University of Toronto Machine Learning Lab, which is well known for creation of deep learning, and have been practicing it ever since with Deloitte for about 3 years now. My observation about the AI and machine learning tools of the hyperscalers as a practitioner that's really building these models is year by year, it keeps getting easier to work with these tools and to work with the packages there. When the hyperscalers started getting into providing AI and machine learning tools, I was initially skeptical, thinking, well, do we really want to go through the effort of getting everything into that sort of environment just to take advantage of the computing? But as time has gone on, I've seen that every year, the packages get easier to work with, the tools get easier to use, and the opportunity for gains for a team by using the tools of the hyperscaler just continues to grow. And I see that continuing. I think this trend is going to continue going in that direction. The same way that cloud computing has become synonymous with the hyperscalers right now. There's not many organizations that run their own clouds anymore. I wouldn't be surprised if machine learning goes that same direction in the long run with the hyperscalers. Lynn, do you want to make some comments as well?
Yeah, for sure. Hi, everyone. Really happy to be here to join the panelist discussion. By way of introduction, I'm a senior manager in the data science team of Deloitte Omnia. I've been with the firm for about 5 years now and in the field of data science for more than 10 years. I've worked with leading the delivery of data science and machine learning solutions for our clients across multiple industries, including financial institutions, insurance, retail, healthcare, etc. And I've recently led the initiative of establishing the MLOps practice here at Deloitte Omnia to help our clients to really realize and leverage this rapid growth that's come with the cloud, and help them to implement machine learning solutions in the production system at scale. So to your point, Kevin and Mario, this is really exciting that hyperscalers are bringing this cutting edge, latest machine learning technology so close to every one of us. And with the excitement, we're expecting to see a lot of rapid growth in the market. At the same time, it comes with nuances in terms of organizations need to think about how to tackle the scaling problem to really capitalize on this rapid growth and achieve the desired value by applying machine learning at scale across the organization.
And that's, I think, where we go next. How do you actually how do you do that? Scaling machine learning in the cloud for both depth and breadth And Kevin, I'm going to guess you'll be in a great position to kick us off in that conversation, perhaps starting by explaining what we mean when we say depth and breadth here.
I'd be happy to talk about that, Delaware. This is a topic I'm quite passionate about, in fact. When we say depth and breadth, we mean exactly the same thing when we talk about depth and breadth of expertise of an individual. Breadth means the ability to address a really wide range of different topics, business problems, and that's use cases, if you will, there. Whereas depth means the ability to achieve deep understanding and superb performance in a more narrow area there. And depth versus breadth is something that I've really observed developing over the last 3 to 5 years in the industry there, especially with respect to machine learning in the cloud there. The initial promise of machine learning in the cloud was all about depth. Depth was the focus, to be able to do things better there. That was how the whole thing started.
Mm-hmm. So has cloud computing therefore delivered on that promise of depth?
It has, and it's done it in ways that were different than what I think a lot of people initially expected. So when we talk about depth for machine learning, it means a couple of different things, and they're a little bit intertwined. So when people talk about depth in AI and machine learning, the phrase deep learning comes to mind. This has become a popularized phrase that originated in academia. When people say deep learning, it sounds like you're building AI systems that deeply understand in the way a person would deeply understand, true depth of appreciation there. That's not actually what the technical term means at all. What it really refers to is the depth of a neural network. So deep learning comes from the world of artificial neural networks, where you create artificial neurons that take in input from sensors or from variables that are passed in. If you imagine in the world of image recognition, each pixel is one of those input points at the beginning of the network there. And then it gets passed through layers of artificial neurons, where the signal gets changed each time it goes through a layer. And then at the very end, you have your output of the network, where you get the final answers that you're looking for. For image recognition, is there a dog in the picture? Yes or no? One artificial network displays that. The innovation of deep learning came around about 10 years ago. So what happened was, as you add more layers to a network, the computing costs and the data requirements grow exponentially. And it got to the point where after more than 3 or 4 layers, it just wouldn't work. You couldn't do anything with it. There were a few technical innovations that spurred the concept of deep learning. And what deep meant was a deep network, more layers in the network. These made it possible to build deeper networks. And that was what spurred the latest wave of artificial intelligence gains, building deep networks. Now, even with these innovations, there's still exponential increases in the computing costs needed to train a deep learning system. And this is where cloud machine learning comes in. Cloud computing allows you to tap into huge amounts of computational power when you need it. And that resolves the time problem. For a lot of the deep learning algorithms that are built today for image recognition or voice recognition, to train them, if you did this on a single computer, it would take years, in some cases decades, to train the network there. But thanks to the hyperscalers, that can be done in hours or days instead. So the time to create these models has changed, making it possible. The cloud machine learning also impacts on the technology side. There's been an evolution of custom hardware to enable these sort of things. GPUs, everyone's heard about, they're fairly accessible. TPUs, tensor processing units, are even more complex hardware that's specific for these sort of applications. They are encapsulated by these cloud systems. So all you need to do is make a function call in your cloud environment, and all of a sudden you have access to these hugely specific, complex processing power to train these things. We felt the impact of this ourselves in a project I was working on with my team, where we were working for a Canadian retailer trying to build a retail demand forecasting system. They were already using the state-of-the-art industry best practices for how to forecast demand. We wanted to see whether a deep learning approach could actually do better. And we took advantage of the tools available for the hyperscalers to train a system based on billions of rows of examples. And what we found is we were able to reduce the inventory carried by about 10% across all the stores, while also reducing what's called stockout events, where the store just runs out of something, by more than half, thanks to the power of the machine learning algorithms from these stores. So that's where deep learning, true deep learning enabled by the hyperscalers, can really help, where you have huge amounts of data and a problem where an improvement of a few percent can really move the needle for an organization there, for those special, unique problems there.
Yeah. This is fascinating, as what I'm hearing you say is that essentially every element that is required to make this work is now accessible through the cloud. It's the infrastructure to host the compute. Then there is the compute power itself that is available. Then pre-assembled, pre-trained algorithms, essentially what you need to bring to the game is your data to allow that particular algorithm to be trained and extract. But essentially everything else, the full stack is really available to anyone at the fingertips.
Exactly right, Dalibor, you've got it.
So is this sounds like a really neat approach to solve this hairy problem that clearly organizations themselves, most of them just couldn't afford to do it in time and in money. Is this happening across all sort of AI use cases, or are there some specific use cases that are, leading the way?
Yeah, that's a great question, Dalibor, because the truth of the matter is, while deep learning is what spurred this wave of artificial intelligence excitement, very few artificial intelligence applications are in fact using deep learning. Most of them are not. And despite that, a lot of organizations are actually benefiting from it in ways that are not always obvious. There was a mention earlier in the conversation around the hyperscalers making talent accessible to everyone else. And that is exactly what's happening in the marketplace. So I have a lot of friends that are professors at university, and I ping them every once in a while to say, hey, have you got any top students that we can recruit? And the inevitable response is, my top 5 PhD graduates this year all got picked up by the hyperscalers. They're all going to Google or Amazon or Microsoft. That's where they all go. So it becomes near impossible for even an organization like Deloitte to directly hire and retain that top talent.
Yeah.
But what hyperscalers have done is they have taken the expertise of that top talent and used it to train these models for very common problems. So problems like image recognition, optical character recognition, converting sound into text, so speech recognition. They are using this top talent to train and build these systems and then making it available through API calls. And that's how everyone gets access to it there. So that makes it more broadly accessible. Mario, I wonder if you've actually had any experience on that and would want to comment on how the hyperscalers have been doing that in some specific ways.
It's interesting. I think a couple of examples that come to mind, there's a couple of areas nationally that are inundated with flooding. And typically the way that they solve this problem is they have city workers who drive by and take measurements of water levels and review weather patterns and really understand whether or not there should be a specific condition. And then this in turn will cause other people to look at how they're going to manage flooding in certain areas, either by turning on dams or floodgates and those sorts of things. I think the advent of using machine learning and IoT devices has provided them the ability to reduce the burden of having someone drive out to a location and take those measurements and get those measurements in real time and look at those models and make predictive calculated decisions as to whether or not to take action or not take action. And I think that that's, pinnacly I'm not saying that we're going to turn into cyborgs or become part of the Borg, but I do think that the ability to capture that data and make real-time decisions in the cloud is super powerful for a number of reasons. One, it reduces the requirement of having someone to go out and make a error in judgment. It ensures that measurements are taken accurately and that it's sort of black and white. And it also, I think the other sort of important piece that I see sort of coming is this concept around making a lot of these models transparent, so that the data points and can be trusted, right? So that's another big thing, that using these hyperscalers to make all these predictions is, can we trust the data, and can we trust the model? Can we trust the output coming out of them to make those decisions? And I think that over time, this has increasingly become, people are increasingly becoming more confident in the approaches and the science behind that.
That's really interesting. I like your comment about trusting the data as well there. That's definitely a theme I've seen recurring all over industry. It's one that we actually addressed in a use case we built not too long ago that really took advantage of the pre-trained models and cloud machine learning capabilities. This was a system we built for situations where organizations with large physical asset inventories are looking to digitize these, but they want to link up the digital asset ecosystems with their drawing images. The problem was they didn't know which asset was present in which drawing, and the records they have, they were not trustworthy. So what we did is we actually built a system that combined the pre-trained models available from the hyperscalers for OCR and image recognition there, together with some custom machine learning libraries to work out, once we've run these documents through the OCR, which elements in the document, which pieces of text represent the asset ID tags that represent those documents. So by putting together those pre-trained capabilities offered by the hyperscalers with some lighter weight custom AI work, we were able to build something that actually outperformed humans on that task, giving more reliable data when you're looking to do maintenance work. And this is something that we've really seen that I've really seen as a trend, which is moving towards that direction of breadth. While there's a few problems where that very deep solution is worthwhile, like optical character recognition, speech recognition, that sort of thing, there's a lot of problems that could be addressed by machine learning in some way. And this is what I mean by breadth. It used to be the case that organizations would look at perhaps one or two use cases. This is changing, though, to organizations thinking about any time where they would like to be able to automate a repetitive task or to forecast something and know what's coming ahead of time. These are all potential AI and machine learning use cases. And the relationship between the effort put in to build the system and the performance you get out of the system it's very nonlinear. It can take as much effort to get a system from 50% to 90% accuracy as it takes to get from 90% to 92% accuracy. As you get higher and higher, the step from 95 to 96% accuracy, that might take 100 times as much time, effort, and compute cost as getting from 50 to 90% performance in the first place. So what's happening is that the number of use cases being addressed with those lightweight, fairly simple machine learning models is really growing. And that's where the breadth dimension has started to come in here. And something that I found is really enabling that is tools for, call it the data engineering and data wrangling side. It's common knowledge that 90% of any machine learning project is the data preparation. And out of that 10% that is the real AI work, 9% is the further data cleansing, and that last 1% is the real modeling work. And Mario, I wonder if you can comment a bit on what you've seen by way of tools for standardizing that in the cloud so that you don't have to do this separately for each use case.
Yeah, it's a great comment. So, I mean, there's lots of tools that are out there from standardization. I've seen great success with Informatica in terms of their tool sets around data governance. Azure and their platform has, and Data Factory, Databricks, using a lot of standards and tool sets and frameworks that are can be leveraged around data governance and managing and data wrangling. So a lot of tools there, whether it's AWS, I think all of the hyperscalers have some form of tool or another. I think what's important is to identify what capabilities are necessary, land on that common framework in terms of understanding what type of data management, data engineering activities need to be put in place, and then marrying that up with the right set of technology tools. There's a myriad of startups even out there that are building, tools. If I think of, someone like a Data IQ that has, a complete sort of data science package from everything from, data management through to data science. Or you think of, whether it's AWS Glue on the Amazon platform, all of them have one tool or another. So I think that there's no right answer, if you will, until you truly understand the types of business problems that you're tackling.
And that's exactly what I'm seeing. More and more business problems being tackled with simple, lightweight models to address it quickly. And I've been seeing changes in the way people operate in those sort of quick, lightweight business models. And Lynn, as an MLOps expert and practitioner yourself, I wonder what you've seen with respect to the ways of doing those lightweight, quick models.
Yeah, that's a great question. I've always kind of advocated that the ultimate driver for machine learning adoption is always the business value. So being able to prove the value quickly and being able to adopt a really agile approach for use case development to be able to start with the minimum viable product, do quick iteration, prove the value quickly, and then build incrementally on that is the key. And now we're seeing that all of these tools are bringing the capability of being able to do rapid experimentation, rapid prototyping, and continuous training to make all of this really possible.
This is really neat, and obviously a lot of things are happening. Many use cases you just described, tools are available. I know from the clients that I work with are embarking on this search for these data scientists, and everybody feels compelled to identify, bring on higher data scientists. And given it is certainly true what you're describing, it almost feels like there should be an army of data scientists in every large organization. Is that true, Kevin?
So strangely, I don't think it will be. I think in the future, in the near-term future, you'll see organizations with dozens or even hundreds of AI use cases implemented, but very few data scientists by trade and by profession doing that. Right now, data scientist it's a role. It's a hot topic, if you will, in the industry. But if you go back in time, there was a time when computer was a profession. It was something that people did. Typist was a profession. I think the best analogy actually is spreadsheets. There was a period of time not too long ago when somebody who knew how to use Microsoft Excel and how to use that to build a spreadsheet, that was an unusual skill set. It was something new. But over time, those skills and those capabilities got distributed among the workforce. And I think you're going to see the same thing happening with data science applications for those breadth of applications. I think with this combination of new tools, with a lot of graduates from business schools being exposed to data science these days, I think what will happen over time is that business users and business analysts will be enabled to actually use these tools themselves for the lightweight model building. The same way that anybody and everybody will build a quick spreadsheet in Excel, this won't be common in the future. So I think what you'll see is for the depth dimension, that will become increasingly specialized with smaller numbers of experts in deep learning building these really complex models. But from the breadth dimension, you're going to see more and more people using this as a capability and as a profession, as you will, as a craft, rather than as a specialized, unique skill set. Yeah.
that's actually a very good point. This is proliferating across the organization. And at this moment, it still is seen as a bit of a sort of dark art and very sort of scientific and bespoke, and don't bother these people, leave them be, and just what you are really describing is a need to industrialize this capability, to view it from being a collection of deep experts into really ML ops, like in that, delivering it at an industrial scale. Now, we did actually talk about this as in our last tech trends, about this proliferation or leading organizations adopting ML ops as a multidisciplinary approach. And I'm curious to sort of hear Lynn's perspectives on that. So Lynn, can you share with us your experience about ML ops? What might be some growing issues, roadblocks, opportunities? How would you describe that?
Yeah, absolutely. Thanks for this, Dalibor. And both Maria and Kevin touched on how we're in this area of having this great most exciting cutting edge machine learning technologies that's closest to us more so than ever. And organizations are putting AI and ML front and center as their main drivers of organizational performance, right? I wanted to share a few numbers from a recent Deloitte survey on the state of AI. 54% of the respondents in that survey mentioned that they are spending more than 4 times compared to the last year on AI applications, and 74 of them said that they wanted to integrate AI to all of the enterprise machine learning models within the next 3 years. However, on the other hand, we're actually seeing many organizations struggling with deploying the machine learning models in production to achieve that desired value. A recent report says that 75 to 80% of machine learning projects failed and moving beyond the proof of concept and testing stage to production. And this is exactly why we need to start looking at adopting MLOps practice to more efficiently being able to move machine learning models from the development stage through to production and management.
So what would be, from your experience, the biggest sort of obstacles and challenges in doing exactly that, taking a concept into production?
Well, as you mentioned, this is the era of industrialized AI and machine learning, right? Yeah. In this day and time, the traditional artisanal model development process are just lagging behind the rapid growth. They're often too slow and too inconsistent to be scalable, right? Many of our clients we work with, they already have their own data science workbench. They have a team of extremely smart, highly professional PhD level data scientists developing and maintaining the models using a more manual customized process. When back in the time when machine learning is a relatively smaller discipline and contained with small group of experts, this would work relatively smoothly and was manageable. However, with cloud making the technology so quickly and affordable, accessible to everyone, the traditional process is just lagging behind to sustain the rapid growth and to be scalable. 20 years ago, similar development and operational challenge was faced in the field of software development, and that led to the birth of DevOps. Right today, it's really AI and machine learning's term for the DevOps treatment. So now we're into MLOps. This is all about standardizing and automating machine learning development, deployment, and management, accelerate the end-to-end life cycle so that we can launch the solutions at scale. Right, the concept was really first brought in around 2015 and rapidly developed ever since. All of the major hyperscalers have proposed their own frameworks, their perspectives, and launched toolkits specifically designed to support MLOps. The market has been growing really rapidly at 50% annual growth rate. And by 2025, we're expecting to see the market size to reach $4 billion.
Yeah, that's huge. That's huge. So clearly, data science as a science and machine learning as a related science, this really ought to be viewed as a team sport, effectively, right? So all of these things that you said, clearly, major transformation for every organization now has ability to tap into this, right? And this is, I think, a hugely transformative for those who have embarked on the cloud transformation and are somewhere along the way. I love the concept of MLOps and you know, growing it up and industrializing it. What we also see is, like, we know the proliferation of vendors and providers and solutions that exist out there. There is the different technologies. Hyperscalers, of course, we know who they are, a small handful of them. And then there are other more bespoke specialist firms or organizations that create their own technology to interact or to leverage your data and integrate with what hyperscalers offer. And then there are vendors and solution providers themselves who can help you develop algorithms. So the landscape is growing and it is complicated. What do you think, or do you know, are the main factors that ought to drive organizations, clients of ours, as they navigate that vendor landscape? What are those things that ought to be driving their choices and driving the adoption?
Yeah, adoption is always a very complex issue to navigate.
Yeah.
And when it comes to machine learning adoption in particular, data is often cited as the #1 challenge, right? Both Kevin and Mary also discussed huge chunk of time spent on building AI and machine learning application is data wrangling. This is undifferentiated, heavy workloads that can be spent somewhere else to solve critical problems, right? So an example of that technology that just came around quite recently is the Amazon SageMaker feature store that was just launched last September to address exactly this challenge for machine learning in particular. So that is built on top of the traditional data warehouse technologies, but also optimized to accelerate the machine learning feature engineering process, right? It is a fully managed and purpose-built repository to store, update, retrieve, and share machine learning features for training and inference at very low latency, right? So unlike traditional data warehouse, a feature store often has a dual database structure. One database serves online application at a very low latency. The other database store huge amount and high volume of data and volume to support the data scientist training job to train and update the models. We're seeing that hyperscalers are entering this market and providing a technology quite recently. Amazon being the first to bring the dedicated feature store solution to their platform, and Google followed very quickly in their newly launched AI platform Vertex platform that was launched in May, where they introduced their own version of the feature store technology. So all of these tools that automate the traditionally like undifferentiated, effortful, heavy workloads, including data management, including the management of infrastructure, computing systems, and required softwares that come with the hyperscalers, are a great way to drive machine learning adoption and help free up the talent so that they can scale, they can focus on solving the more important questions. And I always wanted to come back to the point that ultimately what drives technology and machine learning adoption is business value. Right? So that means the MLOps framework needs to involve business stakeholders throughout the process and continuous monitoring the model performance to make sure that it meets the business objectives. And with that, I would like to open up the floor to Mario and Kevin for them to share their perspectives as well.
Let's go, Kevin first. Kevin,
Yeah.
you are the first one off mute.
Sounds good, Delaware. I've been fascinated to see MLOps growing as a practice. It really is a change from little pockets of work, everybody doing things their own way, to turning this into a real profession where you can standardize it. And I see this as one of the triggers that will allow that breadth of use cases to succeed in a lot of organizations. So I love the perspective that Lynn is sharing, and would invite all of our listeners to really think about this, of how we're going to take AI and machine learning from being these little pockets of expertise to something that's integrated into the whole organization to be able to bring things from start to end. That it is a team sport. That's exactly it. And understanding who are the players on the team and how do you build teams and a structure to the game, if you will, to help them succeed. Because the future of AI and machine learning models is for most large organizations to have dozens or even hundreds of their own, maybe fairly lightweight models, but lots in there, and they need to be managed and handled in a systematic way. Mario?
Yeah, no, I think what you mentioned earlier, Kevin, around time sort of struck a note for me. I've used this tagline with a number of my clients that AI, machine learning, data, and analytics is all about accelerating what I call time to decision. And the longer it takes to get that decision, so the longer that time takes, the less relevant the action becomes that you take once you get the analysis done. So by that, what I mean is, if it's going to take you months, several months to get an answer, by that point, the question has already changed. And so the faster, anything that you can do to reduce that time window of the analysis to get to a decision ultimately favors your ability to gain that competitive advantage, whether it's within a specific business unit or against your competitor, or to reduce risk, whatever it might be. The time to decision is what's critical and key. And I think the advancements in ML ops is really a way of saying, once we've built these models, now we have a way to productionalize them and reduce that I think what Lynn had indicated was a percentage somewhere around 70% of AI business cases don't actually make it to production. And so that's concerning. So anything that you can do that minimizes that time that it takes to do that analysis, build the model, get the decision, and reduce that time to decision, I think is critical for everyone.
So thanks for that, Mario. So now you on this podium, I'm going to go back to you, and then to Kevin and to Lynn. I wanted to know, what would be one takeaway that you would like our audience members to leave with as they think about this cloud-enabled ML in the context of the three-pronged promise that we talked about today: the promise of access to technology, shortening the time, and access to the talent. What would be your sort of key takeaway for the audience? We then go around the room.
Yeah, I think, Delbert, it's a great point. So for me, I really see hyperscalers as filling that void to say, we're running a business. I'm in the business of whether it's supply chain, whether it's retail, whether it's energy and resources. That's my business. I'm not in the IT business. I'm not in the data center business. I'm not in the business of figuring out why I can't connect this system to that system. I really just have a business problem. I'm trying to solve that business problem. How can I do that quickly? How can I reduce that time to decision? How can I be more data driven and insights driven and focused in the decisions that I make with my business and the directions that I take? So to me, the leap to cloud is about, how do I look at, retooling the talent that I have today and into being more, less sort of system savvy and more sort of cloud savvy, and understanding how do I build more of the necessary ingredients to help me move my business forward, right? So whether it's through, moving some of my data in there, leveraging the cloud to do some of these complex algorithms, and then bringing me the decision back, but leveraging in it more, working smarter, not necessarily harder, and having large data centers, I think, has a significant cost associated with it. And I think that the previous series that you had to this one around cyber helps sort of alleviate some of the security and privacy concerns that make it, I don't want to say 100% foolproof, but safer and more comfortable to move data into the cloud to do those complex analyses that are required.
So I would summarize that takeaway as in things are available today for you to solve your problems, business problems, and act on opportunities. Go educate yourself, figure out how to leverage it, right? That will be the essence of that. That's excellent, Mario. Kevin, what would be your one takeaway for the audience?
One takeaway is when you're thinking about a problem, a business problem that you're considering applying AI or machine learning to, really think about whether you have a depth application or a breadth application. Is this a place where a simple, lightweight solution can provide quick business value, getting from that 50, 60% accuracy based on a rule of thumb up to that 80, 90% accuracy from a simple application, in which case MLOps is the way to go. Find a way to do it quickly and consistently. Or is it one of those rare problems where getting from that 95 to 96% level of performance, that jump, that small jump provides real competitive differentiation there. And understanding which of those two each one is will really set you up on the path to business success.
That's a great, insightful advice. Thank you very much for that, Kevin. Lynn, why don't you bring us home and then we'll answer some questions from the audience that were coming.
Yeah, absolutely. For me, sorry, for me, this is really about how machine learning has become a team sport, right? Yeah. With the technologies coming from the hyperscalers, where machine learning is no longer limited to a group of PhD level super smart data scientists. It's in the hands of everyone, and it's a collaborative effort across the whole organization. We can have data engineering engineers, cloud engineers, software developers, all coming together to create customer-centric solutions to solve critical business problems with the technology and focus on value-add tasks.
Excellent, excellent. So, team sport, think breadth, think depth, and know things that are available. You can plug into them. You don't need to be building this yourself. Those are excellent takeaways. I'm going to go and get us a couple of audience questions next. We have about a few minutes to go, so I think we'll have a time for maybe one or two. There was an interesting question about the actual liability that is related to AI applications and the related supply chain of people who have been developing that, that have created that AI algorithms. So I'm going to assume this means the liability exposure to companies who create this, which I think directly is linked to the accuracy, right, and reliability. Anyone can comment on that question. It's a good question.
It's a great question. I think that with any new innovation in technology comes the concept of liability. And I don't think that it's, if we consider, smart home devices, something as simple as a smart lock on your home, what if it makes the mistake and opens the door to an intruder, and now they've taken everything from your home? Is that, do you now go back to the device manufacturer and say, now you owe me all of this, all of the things that have been stolen from my home? Or, if we look at, even in the supply chain world where I may make a decision to pre-order some inventory into my one of my stores, and that purchase order, was erroneously, and now I have all this inventory that I can no longer sell. So I think that inevitably it's about, I don't know that we have the answer today, but I think that we are definitely trying to figure this out. I think trust in the data is growing over the years. I think that if I look at the pandemic and all of the things that have happened, they've contributed to what I would call sort of a mistrust in data and an attitude where people are wanting to see more transparency, and AI needs to bring that transparency to bear to everyone, both the consumer as well as the business itself. They need to ensure that they are transparent with people purchasing their products and their services, so that they can trust in the data. So I think liability is carries a little bit of a legal connotation around who's ultimately going to pay if I am burdened by the wrong decision. And I think that that's something that we continue to sort of look at. I don't know that we have the right answer, but I think that, that's going to be something that each business will need to understand in terms of the burden of truth, in terms of, who is ultimately liable for something.
And obviously the combination of trusting in the data, so data that is orderly and right data, combined with explainable AI algorithms, will provide an element of answer to that question. Thank you very much. Before we close, last question, maybe this one to Kevin. A question here is there a specific size of the organization that it needs to be before they can really benefit from AI, ML in the cloud?
So I think the size has been changing over time. It used to be only very large organizations could justify doing this. But as breadth has come into play, I've seen smaller and smaller organizations, some as small as $10 to $20 million a year revenue organizations, actually build their own and benefit from their own AI and machine learning applications, but generally on that breadth scale. To really benefit from the depth scale, it tends to be larger organizations, the $1 billion plus organizations.
Yeah, and that it sounds like that is sort of that curve is shifting. So thank you very much for that. Audience members, we are now at time. I want to thank you all very much for your attention, for the questions. I want to thank the panelists for your insights. This was very, very educational for me as well. Of course, if audience members have any follow-on questions for our panel, please do send them to me. I'll broker those questions and introductions if needed. And I will invite you to join us for our final episode in our Future of Cloud series, which is happening 2 Wednesdays from now on July 28th. And at that episode, we are going to talk about the implication of cloud and the future of cloud as it relates to talent. This is a major topic of major importance and direct relevance to all of us who are on these calls. So I look forward to hearing the conversation on that. So until next time, thank you very much. Give yourselves a lovely Wednesday. See you 2 weeks from now. Bye-bye.
Bye, everyone.